Welcome, my name is Spyros Zigouris. I am computer science professor and you are on videolearner.com. Through this channel you'll find complete lessons and explanations for the International Baccalaureate Diploma Program in Computer Science.
Hello guys, I hope you're doing great. Today we are talking about CPU and GPU memory access. In earlier lessons we examined how the processor communicates with the main memory, which is RAM. We also learned that the computer uses three primary system buses: address bus, control bus, and data bus, to transfer data. We learned that the main registers within the CPU store the current instruction or data. However, today we are focusing on the different levels of cache memory. Memory access in the context of computing hardware such as CPU and GPUs refers to how these processors retrieve and manipulate data stored in computer memory. Each type of processor handles memory access in its own way, based on its architectural design, which impacts how well it performs. CPUs utilize a memory hierarchy to manage data access in an efficient way. This hierarchy typically includes several levels of caches: Level 1 cache memory, Level 2 cache memory, and sometimes Level 3 cache memory. This hierarchy is optimized to minimize memory latency from issuing a memory request to receiving the data. As you can see here, right next to the core, we have Level 1 cache memory is the one with minimal latency, the fastest one. We have Level 2, faster, Level 3, fast, and so on. CPUs typically run in settings with several cores, so they rely on cache coherence protocols. These protocols keep each core's view of memory aligned, which helps avoid data conflicts and preserves the integrity of shared information. Modern GPUs often use a unified memory architecture, which allows them to access a large, shared pool of memory which both the GPU and the CPU can address. GPUs are designed with high bandwidth memory. These memory types are optimized for the high throughput requirements of GPU tasks, enabling fast data transfer rates that support the processing capabilities of hundreds to thousands of parallel cores. Unlike CPUs, which are optimized for low latency access, GPUs prioritize memory throughput. To summarize memory access, CPUs utilize low latency memory because they need to rapidly switch between tasks, retrieve data from memory, and execute operations based on that data with minimal delay. On the other hand, GPUs utilize high memory throughput because they handle large volumes of data and need to feed hundreds to thousands of parallel cores simultaneously. And that's all. We just finished CPU and GPU memory access. In the next lesson, I'm going to talk to you about power efficiency. From Spyros Zigouris, my YouTube channel, and videolearner.com. Bye bye.